Okay, so we'll do a little summary of what we've learned about graphing logarithmic functions. Okay, so this is f of x, and it's got, all the pieces here, a, c, and d, and it's based on a parent function. In this case, it would be g of x equals log base b of x. Okay, so if that's the parent function, we don't know what the base is, b, but if that's the parent function, then we can do these transformations based on the parent function. And by the way, b has to be greater than 0. It has to be positive. Okay, so what does d do? D says that's going to be a vertical shift. If it's positive, it'll shift up. If it's negative, it'll shift down. What does C do? C is going to shift. If C is positive, it's going to shift left. And if C is negative, it's going to shift right. Okay, so they didn't mention that in the book, but it's the way it is. Okay, now what about A? What does A do? Well, the absolute value of A, if that's greater than 1, then it's going to be a stretch. And if the absolute value of A is between 1 and 0, then it's going to be a compression. And then if whatever A is, if it's less than 0, meaning it's negative, so not the absolute value, but just A, if it's negative, then it's going to reflect about the x-axis. And then just one more note, well, I'll put it over here. If you have f of x equals log the opposite of x, and this is base b, then it's going to reflect about the y-axis. Okay? So it's kind of a summary, trying to put it all together here a little bit. We want to know what the transformations are. We want to know what it looks like. Our graphs aren't going to be perfect, but we want to know what those different pieces in the logarithmic equation are doing to the graph. Okay? So we don't spend a lot of time on this. It does in this section, but we're going to do some other things with logarithms in the rest of this chapter.